In question number 15, consider two parallel uniform rods parallel to y-axis, each of mass m and length L. Velocity of center of mass of each rod is 2v naught I cap and the angular velocity is omega. A particle r of mass m is moving with velocity v naught I cap parallel to the velocity of center of mass of each rod as shown. On the basis of our information, choose the correct match, and it is given v naught is equal to omega L by 2. So in the entry P of list 1, kinetic energy of rod AB with respect to r. So if I write the kinetic energy of rod AB with respect to r, then I have to use the theorem of kinetic energy, that is the kinetic energy of the system of particle with respect to center of mass plus the kinetic energy of center of mass plus half m VCM with respect to frame of reference. So if I write the kinetic energy of the system of particles with respect to center of mass, that is half I omega square. So half I is ml square by 12 into omega square. So half I omega square plus half m VCM. So m is m. So if I find out the velocity of center of mass of this rod with respect to this point, so the velocity of center of mass is v naught, so v naught is square. So if I solve this, it comes out to be 2 by 3 m v naught square if I substitute the value of omega as 2 v naught by L. Similarly, if I write the kinetic energy of rod PQ with respect to r as given in entry R, so kinetic energy of rod PQ with respect to r can be written as half I omega square, so ml square by 12 into omega square plus half m VCM square. So half m velocity of center of mass with respect to this frame is v naught square. So this also comes out to be 2 by 3 m v naught square. So the correct matching for entry P is 5 as well as for entry R is also 5. Let's check the entry Q. Angular momentum of rod PQ with respect to the center of rod AB. So we have to find out the angular momentum of this rod with respect to the center of this rod AB. So angular momentum of rod PQ can be written as plus angular momentum of the center of mass with respect to frame of reference. So I into omega, so I is ml square by 12 into omega, and the sense of rotation of this rod PQ is clockwise, so minus k cap plus, so the velocity of this center with respect to this center is 0, so their angular momentum is 0. So if I solve this, it comes out to be m into v naught L by 6 into minus k cap. So the correct matching would be 1. If I check the angular momentum of rod AB with respect to R, so the angular momentum of rod AB with respect to R can be written as I into omega, so ml square by 12 into omega, omega value is 2 v naught by L, and if I check the sense of rotation, the sense of rotation is anti-clockwise, so that is k cap plus the angular momentum of center of mass with respect to frame of observation. So with respect to this frame of observation, the center of mass is moving in this direction with a velocity of v naught. So its angular momentum can be written as mvr. So plus m into v is v naught and r is L by 2. And the sense of rotation is clockwise, so that can be written as minus k cap. So if I solve this, it comes out to be m v naught L by 3 into minus k cap. So the correct matching of entry S is 2. So if I check the options, then option C is the correct answer. Let's move to question number 16. In question number 16, 2 moles of helium and 2 moles of oxygen are mixed with each other. 100 R amount of heat energy supplied to the gas sample through different processes which are given by expression in list 1, and list 2 contains rise in temperature in different processes as given in list 1. Choose the correct options. Symbol have their usual meanings. So if I calculate the CV mixture, then CV mixture is given by the formula N1 CV1 plus N2 CV2 divided by N1 plus N2. So the first gas is helium, which is monoatomic. So we can write 2 into CV for the monoatomic is 3R by 2 plus second gas is oxygen, which is diatomic. So 2 into 5R by 2 divided by 4. So if I solve this, it comes out to be 2R. So CP mixture can be written as 2R plus R, that is 3R. Now if I consider the entry P of list 1, then this can be written as D of rho T is equal to 0. It implies that rho T is equal to constant. So if rho T is equal to constant, it means the pressure is constant. So it is a isobaric process. So in case of isobaric process, we can write delta Q, that is 100 R, is equal to N, total number of moles, that is 4, into Cp. So the value of Cp is 3R into delta T. So from here, the value of delta T comes out to be 25 by 3 Kelvin. So the correct matching will be 3. If I check the entry Q, then this can be written as PV raised to the power half is equal to constant after solving of differential equations. So if I compare with the polytropic process, PV raised to the power x is equal to constant, then the value of x comes out to be half. So if I find out the molar heat capacity in this process, that is CV. So CV mixture is 2R plus R divided by 1 minus half. So it comes out to be 2R. So the summation is 4R. So in this case, delta T, so in this case, if I write the delta Q equation, that is 100R is equal to 4 into 4R into delta T. So from here, the value of delta T comes out to be 25 by 4 Kelvin. So the correct matching for Q is 5. In entry R of list 1, pressure is proportional to density. So when pressure is proportional to density, it means the temperature is constant or it is an isothermal process. So in case of isothermal process, delta T becomes 0. So the correct matching would be 1. And in the last, if I solve these differential equations, then it will take the format of d of V into T is equal to 0 or T into V is equal to constant. We know that for an ideal gas equation, PV is proportional to T. So this can be written as P into V square is equal to constant. So on comparing with the polytropic process, the value of X becomes 2. So the value of C can be written as 2R plus R divided by 1 minus 2. So minus R. So it comes out to be R. So 100R is equal to 4 into C, that is R into delta T. So from here, the value of delta T comes out to be 25 Kelvin. So 2 is the correct matching. So in this case, if we check the options, then option D is the correct answer. So the correct answer for question number 16 is option D. Let's move to question number 17. In question number 17, a source emitting sound of frequency 100 Hz is moving towards a vertical wall with a speed 20 meter per second as shown. Wall is also moving towards source with a speed of 10 meter per second. Wind is blowing with a speed 5 meter per second towards the wall. F1 and F2 are the frequencies directly observed by observer 1 and 2 respectively from source, and F1 dash and F2 dash are frequencies of reflected wave observed by observer 1 and 2 respectively. The speed of sound in air is 320 meter per second. The observers are at rest. On the basis of above information, choose the correct match. So first of all, we have to find out the value of F1 and F2, which are the frequencies directly observed by observer 1 and 2 from source. So we know that In case of Doppler effect, the apparent frequency f dash or f apparent is f naught into v plus minus velocity of observer divided by v plus minus velocity of source. So plus and minus sign are taken with respect to the sense of motion. So if I calculate f1, then f1 can be written as f0, which is 100, plus the speed of sound in the given medium can be written as, so with respect to this observer, the sound will move in this direction and the velocity of wind is in this direction. So this can be written as 315, the velocity of observer is 0, divided by 315. Now the source is moving away from the observer. So if the source is moving away from the observer, then this can be written as plus the velocity of source, that is 20. So if I solve this, it comes out to be 94 Hertz. So the correct matching would be 4. And similarly, if I calculate f2, the value of f2 is 100. Now for this observer, the velocity of sound in this medium can be written as 325, as the velocity of wind is in the sense of the sound waves, is in the sense of the speed of sound. The velocity of observer is 0 divided by 325. Now the velocity of source is towards the observer, so that can be written as minus 20. So if I solve this, it comes out to be nearly equal to 107 Hertz. So the correct matching would be 1. Now I have to calculate what is f1 dash. So in order to calculate f1 dash, first of all, we have to find out what is the frequency f1 observed by the observer. In order to calculate f1 dash, first of all, we have to find out what is the frequency received by this wall if it is considered to be an observer. Let this is f1. So the value of f1 can be written as 100 into, so for this observer, this has to be written as 325, and the observer is moving towards the source, so plus 10 divided by 325, and the source is moving towards the observer, so minus 20. So this is the value of f1. Now for f1 dash, I have to write f1 into, now this is source and this is observer. So for this observer, the source signal moves in this direction and the velocity of wind is opposite to that. So this can be written as 315 minus velocity of observer, that is 0, divided by 315, and the velocity of source with respect to this observer is moving closer. So this can be written as minus 10. In the same fashion, I have to write for the f2. In the same fashion, I have to write for the observer 2, that is f2 dash. So we can say that this f2 dash is same as that of f1 dash, because both the observer are on the same side of the source, that is wall. So if I solve this, if I substitute the value of f1 and solve this, this comes out to be nearly 113 Hertz. So the correct matching would be 2 and 2. So if I check the options, then option B is the correct answer. Let's move to question number 18. In question number 18, a charged particle of mass m and charge q enters inside a uniform magnetic field B vector is equal to 4i cap plus 3j cap Tesla with velocity 10j cap meter per second at t equal to 0 from origin. If the ratio of q by m is equal to 1, then on the basis of above information, we have to choose the correct match. So let's analyze the situation. Let this is x-axis and this is y-axis. If I find out the direction of magnetic field, then the magnetic field is in this direction, that is 4 I cap plus 3 j cap. So this angle is 37 degree and the magnitude of magnetic field is 5. The velocity initially is along y-axis, that is 10. So if I take the component of this velocity along magnetic field and perpendicular to magnetic field, then V perpendicular component would be, if this angle is 37 degree, then this angle is also 37 degree. So 10 cos 37 degree. So it comes out to be 8, and V parallel is 10 sin 37 degree. So it comes out to be 6. Now let's check the entry P of list 1. Maximum possible magnitude of Z coordinate in meter. So the particle is negative in nature. So if I keep the fingers of my right hand in the direction of the magnetic field and thumb in the direction of the V perpendicular direction, then palm represents the direction of magnetic force experienced by the charged particle. So when the charged particle is positive, it will experience force in the negative Z direction. But since the charged particle given is negative in nature, so at this moment the charged particle will experience force along positive Z axis. So in that case it will move. So the maximum Z coordinate of the charged particle becomes 2r. So Z max is 2r, and 2 into r can be written as m into V perpendicular divided by qb. So this can be written as 2 into m by q ratio is 1, V perpendicular is 8 and b is 5. So this comes out to be 16 by 5 meter. So the correct matching is 5. Now in entry Q, time when Z coordinate is maximum. So the time of revolution is 2 pi m by qb. So m by q ratio is 1. So this comes out to be 2 pi by value of b is 5. So the time taken to reach the maximum Z coordinate is capital T by 2. So this comes out to be pi by 5 second. So correct matching would be 1. If I check the entry S, time in seconds when charged particle touches XY plane. So charged particle touches XY plane when it completed one revolution. So in that case, the time period will be equal to capital T. So that is equal to 2 pi by 5. So 3 would be the correct matching. Now if I check the entry R, component of velocity along x-axis when Z coordinate is maximum. So when Z coordinate is maximum, at that moment V perpendicular is in this direction at the maximum point, and if I take the component of this V perpendicular in this direction along x-axis, then this can be written as, if this angle is 37 degree, then this angle is also 37 degree, V perpendicular sin 37 degree, plus the component of velocity due to V parallel in this direction. So V parallel cos 37 degree. So if I substitute the data, V perpendicular is 8, sin 37 degree is 3 by 5, plus V parallel is 6, into cos 37 degree is 4 by 5. So if I solve this, it comes out to be 48 by 5 meter per second. So the correct matching would be 2. So if I check the options, then option C is the correct answer. So the correct answer for question number 18 is option C. By this, I wish you all the best for your preparation. Have a good luck.